question to us. So as I mentioned, we're covering off concrete joints and sealing systems. We've got Celia Lim joining us from Singapore. I'm going to get started with the first half of the presentation, and then I'll hand over to Celia. So why do we need joints in concrete? Why can't we just create massive, long, big slabs? There's a lot of reasons. One, by putting a joint in the concrete, you're actually relieving tensile forces within the structure. It prevents stresses, which could result in cracking in the concrete. And it changes the reaction forces in structural members. So in other words, you can transfer between members just shear or shear and bending. And also, finally, it allows for construction sequencing. So you can't just pour an entire building in one go. Obviously, you've got to build in little bits. So these are all the reasons why we need joints in concrete. The purpose of joint sealing systems, they offer concrete durability, stopping contaminants getting in. They allow free movement of the concrete during service life, and we'll be talking a lot more about that aspect. They also offer chemical resistance, and they offer protection to subbase of pavements, so stop those from being washed out with water and other things entering and deteriorating the subbase. So let's go back to concrete volumetric stability, which we've spoken a fair bit about over the last few weeks, but I'll just summarise with a few reasons why concrete moves. So, and it's important to recognise this because in the early stages, we have things like drying shrinkage where moisture is lost during curing and evaporation. Most of the drying shrinkage occurs within the first 56 days, particularly the first 28 days, you get a lot of that shrinkage occurring. As time goes by though, that becomes less of a factor, the drying shrinkage. Higher water content causes more shrinkage. So we know all this from our previous webinars. We also have plastic shrinkage. This is due to a lack of water for hydration. Occurs in the first hours prior to initial set and occurs where the evaporation exceeds bleed. So this is something that will happen very early in the concrete's life, doesn't really impact what happens later during the service life. Then we also have thermal shrinkage. This occurs as the concrete cools. It appears and occurs within the first few days of casting, just as that concrete, which is heated up due to exothermic reaction of the cement particles, the entire structure then cools down and we end up with shrinkage. And larger sections create more heat and undergo more shrinkage. But again, this is something that happens very early in the structure's life. It's not something that occurs during the service life. Once we move into the service life, that's when we start seeing things like thermal expansion and contraction occurring. So these will occur through the entire life of the structure. It's due to the daily and seasonal temperature variations. We approximately have, and this is just an approximate value, but around 1 millimetre per metre for every 10 degree of temperature change. Exposure to sun and storage of hot liquids is going to increase these fluctuations. So the concrete is continually expanding and contracting during its service life, and obviously this is going to have a big impact on the way the structure reacts. And then cracking due to volume changes. This can occur where volumetric changes are actually restrained. So if we restrain that movement, where the movement joints fail to operate as per the design, you can end up with cracking, where the movements exceed the creep capacity of the concrete. So concrete can actually absorb a small amount of movement at different stages of its life, depending on how that movement occurs. And it also, cracking can occur where volume changes are higher than the design allowance. So all of these come into consideration when we're designing the joint system for a structure. So the types of joints that we see in concrete, just summarising a few of them. Construction joints, these aren't designed for movement. They're included for construction staging only. They can transfer all types of load. So this is basically the end of one pour and the start of another pour. And when I say construction staging, that's as much concrete that usually can be poured practically either in a day or at a time, depending on the circumstances on site. So this is just stage one, moving to stage two, and this is a connection between the two parts of those concrete elements. Movement joints, on the other hand, they're still a joint in the concrete, but they actually allow movement to occur. Usually that's in a single plane and it relieves tensile forces. Typically, a movement joint will be designed to transfer shear, but not always. The photo of the diagram you can see there, that's a shear transfer joint. So the end dowel is actually sleeved and it's allowed to move in and out. And as you can see, it's moving in that one plane and it's relieving tensile forces from the structure. We can also introduce saw cuts and we can have induced cracking into the structures. This is a methodology used to initiate cracking in a controlled location. It prevents undesirable shrinkage, cracking occurring randomly, so that we're actually controlling where it occurs. The timing of cutting needs to be early enough after casting, and we can also insert inducers, which Celia is going to talk about. We can place those top or bottom, and those inducers will thin the structure and ensure the cracking occurs where we want it to occur. So that's what the purpose of a crack inducer. Sealing of the joints in concrete can be done in a number of ways. Celia is going to talk about this in a lot more detail using gun grade and pourable sealants. These usually have a slightly lower movement capacity. Very good surface preparation is required for these, and we'll discuss why that's the case. We need priming. The concrete must be fully cured before application. There's two reasons for that. One, it'll improve your bond because the moisture content in the concrete will be more suitable. But also after the curing, a lot of your shrinkage has occurred, so then there's less strain placed on those joints as well. It's suitable for both construction and movement joints, but typically not a high amount of movement as a percentage. We can also use strip adhesives. These come under various names, but these have various high movement capacity. They do require traffic protection if they're going to be exposed on the surface. Very good surface preparation is required for these, again, because it's a bonded system. We weld all the joints of those strips together and we seal the terminations, and they're suitable for fairly high movement joints, and they can be used in a number of different ways. We also have a press-in seal. This is just a push-in rubber seal, very easy to install, chemical resistant, it's durable, and usually used just to keep contaminants out of the joints so that we can allow that, that free movement of the slabs. Hydrophilic seals, these rely on expansion within a joint, so they'll develop compression by expanding. Not typically suitable for joints with high movement because they may not expand enough. A little bit unreliable in large structures, and somewhat uncontrolled type of sealing, but still have their place in sealing joints. We have water stop, various profiles available. We can use rear guard water stop or center guard water stop, typically all welded together in a loop, and they'll stop water from traveling through the joint from behind and coming into the structure. So important to point out that some of these systems are designed for water and contaminants entering through one side. Other systems are designed to stop water coming through the negative side. We also have bridge expansion joints. These are for ultra high movement, very high load carrying capacity. You've seen these at the end of bridges with the various types of designs of tooth structures that allow the movement in and out, very large range and still able to carry load. So they're the types of joints that we use in different applications. We're going to focus today now a little bit on airport pavement joints. And Celia from QuickSeal has done a lot of work with airports like Changi Airport. So I've asked her to come along today and just run us through what they do for airport pavements. So I'll hand over to Celia. I'm controlling her screen, so hopefully the timing of that goes well. Over to you, Celia.
Hi, yeah, thanks, Daniel. Yeah, I'm Celia from QuickSeal. Today I'll be diving into the sealing materials for airport pavement joints. Airport becomes busier and more congested as the number of flights and passengers increases throughout the globe. It is then critical the pavements are designed, constructed, and maintained to withstand the imposed load, performed in adverse weather conditions and other deteriorating influences. It is also essential to provide a clean and level concrete pavement at the taxiways and parking aprons. With this, it prevents disruption of aircraft operation and improves airports' operational safety. Yeah, the best practices to ensure long-term durability of pavements. As we know, it is not practical to construct a continuous slabs without joints. Therefore, it is always important to seal the longitudinal and transverse joints in concrete pavements for durability. The usage of control crack inducer to control crack forming on the concrete after cast and forming straight joints in parking aprons and taxiways is an important step to ensure the pavements are correctly constructed. The implementation of comprehensive maintenance program, which includes periodic check around airside to pick up any defects which may have formed so that it is repaired early, to prevent further deterioration on the slab. And this is essential to deliver good ride quality for the safe operation of aircraft and minimize potential of foreign object debris. There are a few types of sealing materials for airfield usage, and it's important that we select the correct type to minimize the defects occurrence on site. They are broadly categorized under form-in-place and compression seal type. Under the form-in-place sealant, it is divided into hot and cold applied sealant. The hot pour sealant was the first type of form-in-place sealant which requires heat to melt the bitumen block into liquid state before placement, and as technology advances, low modular sealants like silicone, polyurethane, and polysulfide, they are made available with improved qualities, and these do not require hot works. Compression seal, on the other hand, is factory manufactured, as you can see from the earlier slides shared by Daniel. It is placed by inserting the seal into the joint and is typically a neoprene base. And it allows aircraft traffic right after placement as no curing is required. Why do we need to seal joints in concrete pavements? Concrete contributes to several pavement distresses and is therefore important to effectively seal the longitudinal and transverse joints in concrete pavements. Sealant is required to minimize infiltration of surface water and isolates joints from fuels and de-icing chemicals, and protects the pavement against spalling, subgrade softening, and downward bar corrosion. By sealing the joints, it also prevents incompressibles from entering the joint and foreign object debris issues that has a capability to damage an aircraft. It also reduces pavement joint blow-ups, which refers to an upward buckling of pavement on both sides of a joint, as you can see from the diagram on the right. An uplift of the pavement, and this is normally caused by the presence of incompressibles in the joint, obstructing slab expansion in hot weather. High requirements are placed on joint seals at airfields, and sealants are expected to resist jet fuel, petrol, and lubricants, and exhibit blast resistance. There are a few specifications available in the market, like the BS 5212, the British standard, and the EN 14188-2 European code. The Changi Airport Group has adopted the EN 14188 as one of the requirements for sealant, as the BS 5212 was made obsolete a few years ago. In the specification, the sealant must remain permanently elastic, ability to stretch or deform to accommodate joint movements. A low modular sealant is preferred due to its ability to stretch and compress elastically. The sealant must also possess the resistance to tearing under tension. As it is an open space application, it is important that the sealant must resist aging due to climatic conditions, including UV exposure and temperature variation. It must exhibit compatibility with the surface in contact, like baccarat and concrete, and possess short opening to traffic time of no more than 3 hours to allow aircraft traffic in times of emergency. Now we come to airport joint seal methodology. Joint design is a critical consideration, and the width to depth ratio is also a consideration to facilitate proper installation and allow sealants to function properly. The joint width is dependent on the climate, slab dimension, and other local factors, and this is usually determined by the structural engineer. A 2 to 5 mm recess below the surface is required to prevent tire contact of the aircraft. The initial joint should be wide enough to allow for effective cleaning. It is generally recommended to have minimum joint width of 8 mm and no limits for maximum. However, provision is required if width is wider than 20 mm to limit the risk of mechanical damage. Joint preparation. Substrate preparation is an important element in the sealant installation to ensure the joint is properly sealed. After cutting, it is important to remove all debris or loose particles from the bonding surface by high pressure water jet and dry using compressed air. A cleanliness check is recommended by gliding along the sides with your finger or a test cloth and do a visual check if there's high level of contaminants pickup. Moisture check on the host concrete is necessary to ensure there is no excessive moisture within the concrete. As we know, polyurethane and polysulfide system will require a dry surface for bonding. After the substrate preparation is done, a closed cell backer rod is inserted into the joint. Closed cell backer rod is one of the important component in a joint sealant installation. There is no specific national specification, but a filler that does not absorb water and moderately compressible will deem suitable for use. It prevents sealant material from flowing out downwards and prevents third-sided adhesion, and this can be clearly illustrated from the diagram here on the right. When the sealant is adhered to three sides, the ability to accommodate the movement when the slab opens and closes is limited, and thus it may cause or it may result in tearing or adhesion failure within the joint. It optimizes the quantity of sealant used, and it helps to create the right sealant thickness by using a 25 to 30% bigger than the joint width so that it stays in place at the desired depth. It helps define the shape factor, which is the width to depth ratio. And this is important to determine the correct sealant depth with respect to the joint width. And we will show you in the later slide how to derive the right sealant thickness and joint depth. Okay. It is essential to use the right tool and skill set when installing the sealant, and this is usually done by the specialist. Understanding the recoat window of the primer is important to achieve good bonding with the sealant. Normally, the sealant is applied when the primer is left to dry for about 30 minutes until it reaches tech-free stage before it receives the primer to create the bond. Normally it will not bond when the primer is wet, when the sealant is installed, when the primer is still wet. Yeah, so these are some of the informations the applicator has to be made known, and they have to understand clearly from the manufacturer before they start application. For multi-component sealant, that we do not recommend partial mixing as this could result in incorrect mix ratio of the base and hardener component and cause impact to either improper curing or durability of the sealant. We'll look at an example of a joint dimension, say a sealant width of 15 mm here. With the formulation to calculate sealant depth, you will arrive at a thickness of 11 mm for the sealant, a recess of 2 to 5 mm, which is required to prevent tire contact with the aircraft, and then a 3 mm gap when the backer rod will become oval when compressed in the joint, some spare space below backer rod 3 to 5 mm, and this number will vary according to the project needs. And then a backer rod diameter of 20 mm with respect to a width of 15 mm, you will arrive at the total joint width of 39 to 44 mm. With this configuration, the sealant will achieve the correct shape factor, which is the hourglass shape, which will contribute to an effective seal. Failure types and quality control. There are commonly three different types of failures that is observed on site. The Asian failure, which is represented on the diagram on the right-hand side, is a detachment of the sealant from the host concrete. And this is commonly attributed by poor substrate preparation, wrong timing installing the sealant after primer application. This is referring to the primer recoat in window, improper sealing material used, or excessive moisture within the concrete. Cohesion failure refers to a tear within the sealant, represented in here in this example. This happens when the sealant is not able to withstand the internal stress induced when the sealant is extended. Incorrect joint design, if the width to depth ratio is less than 0.5 or the sealant is filled to a deeper depth than required, it can be also a case that the application was done without a backer rod and sealing material loses its ability to perform due to aging. Extrusion of the sealant from the joint occurs when the sealant softens or when the sealant is being compressed. This could be due to incorrect sealing material, reaction with the hydrocarbons at the airfield, or no recess was done during application. Yeah, these are some of the photos that was taken on site. On the left-hand side, you will see a cohesion failure, and this is attributed by a lack or not sufficient thickness of the sealant applied over the backer rod. And then in the middle, you have a case where the adhesion came out loose, possibly due to poor substrate preparation, or even there was no primer applied. Right, and the last photo here again showing adhesion failure between the sealant and the host concrete. It is important to check that the sealant is installed properly so that it delivers a watertight seal and minimize any defects during the service life. You can achieve this by performing a simple hand pull test on site to determine if the adhesion is sufficient along both sides of the joint. It is performed after the sealant has been cured sufficiently. This test is destructive to a portion of the sealant joint, which will require to reseal the removed portion after test. So basically what you need to do on site is do a knife cut across the width of the joint, make two lengthwise cuts of about 50 mm along each side, grabs the free end, 25 mm from the bonding edge, and do a 90 degrees pull till the sealant elongated to about 140 mm. You have a rule, place a ruler at the side to measure the distance traveled. As long as there is no debonding occur along the sides of the joint, the adhesion of the sealant to the host is deemed good, and the installation is successful. We have touched earlier on the usage of crack inducer used during rigid pavement casting. It controls the crack location forming on the concrete after cast. It also aids in forming straight joints and is available in 4 depths to suit the slab thickness. The slabs, the size selection is generally between 1/3 to 1/4 of the slab thickness. So basically what you do on site is you insert the crack inducer when the concrete is still wet, and after the concrete has set, remove the top portion. The triangle portion is detachable. Remove the upper portion, and you leave a gap to receive the backer rod and the sealant. Yeah, back to you, Daniel, for the summary.
All right, thank you for that, Celia. Good to see some insights into some airport work there that we usually don't get to see. So just in summary, the concrete does require controlled allowance for movement to be able to function correctly. We now know that. Good design detailing will add to the structure and pavement service life. and also good quality pavement joints that are well maintained are going to reduce disruptions and also the occurrence of safety issues. So jointing a really important part of concrete and structural maintenance. That's it for today. I just popped up my contact details and also Celia's if you've got any specific questions. You can also request a copy of these slides just by clicking on the link that Aidan has just popped up there in the chat box. You can also request other information through that link. No questions there. Thank you very much for joining us again today. We look forward to another week of presentations. Thank you very much to Celia for helping me present today. It's very much appreciated, and we'll see you all again soon. Thank you.